So this session is recorded. I am Edison for those that do not know my name. And I'm part of the mentors, with Achilles Acacia Ventures, where it is a research and innovations firm. We basically look into the challenges within the industry, you know, um, that are going on, and then we build solutions for them, and so that we can help our communities. So we have a lot of work ahead of us, to go to the different industrial startup, agri-tech, fintech, and find out what challenges are they facing, and then we try to address, not try, but we get to address the challenges in terms of building solutions. And in building solutions vary really because you could be building a solution, that is within the agri-tech, agriculture kind of sector. Another person would be building a solution that falls within the fintech, the financial area or sector. Another person will be building something that falls within the health sector. So you find that when you are a tech expert or professional with a specialty, maybe you're into data science, you're into artificial intelligence, you're into machine learning, you're going to need to be flexible. You're going to be flexible because you'll receive a phone call. Today you may receive a phone call to do with health, and the following week you're getting a phone call and it's to do with agriculture. So you're gonna need to be flexible. You don't need to tell them that, hey, me, I hate agriculture, I know nothing. You need to read. You need to be flexible. So this is where I ask, can you all hear me? Mm-hmm.
Yes, yes.
Can you? Nice, fantastic, great. So you need to be really, really flexible, because the world requires flexible people, especially if you're going to be one of the creators of tomorrow. You're going to need to be flexible. So you all know our schedules. Monday, we go remote. We cover the entire data science. We look at machine learning, AI through. We've been having two sessions, but part of our team went into the different competitions with the Central Bank, Bank of Uganda competitions, and they've been doing good. They've been doing good, and that's the thing. That's the thing about being part of this ecosystem or community or Achilles Acacia Ventures is, we equip you, we mentor you, we give you the skills, and you're able to compete globally and nationally. And that is it. CPU, because you're going to burn your CPU at times with the different projects that with the different projects you might be handling. There are projects that may not may not be worth may not suit your CPU, if I'm to simply use that particular word. And then there are projects that will suit your CPU, you know. So you need to know, so that you don't burn your CPU memory. Otherwise, it's gonna be crazy for you. And that's some of the things that we're going to get to understand. And also, your computer may not support, the different installations that we need. And you just need to use the cloud for that case. So, and those are some of the challenges we saw in the beginning, but I made sure people install Anaconda so that they can understand, and we saw the challenge along the way, and that was a very good experience, so that you can get to know. So let's run through this. I'll talk about the CPUs, I'll speak about the GPUs, I'll speak about all those different things that you need to know as we move forward. So today we're going to start a project. which I've called the Industrial Data Science Training Project. This is week 6. That means we have only what, 2 weeks. So we're going to look at precision agriculture and predictive analytics for Ugandan coffee farming. I understand someone called Rachel is looking deeper into coffee, and that's why I thought about this. And I'm like, she's dealing with coffee. She's looking at the data sets. She's scratching to find them. I think let me do something on coffee so that I can boost the idea. And also looking at we are from Africa, and the biggest cash crop you're going to speak about is going to be coffee today. In the market, if you look at Western Uganda, the biggest export is almost coffee, among others. So I felt coffee would be easy for everyone to grasp it, and maybe maize. You'll see maize later as we go down. Okay, Rachel, you're welcome. So let's run through it very fast. The project overview: as you enter your 6th week of internship, we are moving from basic data handling to industrial intelligence. This project simulates a real-world smart agriculture, smart farming deployment, and we will build an AI system that analyzes soil chemistry and weather patterns to recommend the most profitable crops for Ugandan farmers, especially focusing on the optimization of coffee, maize, and rice. So I thought this will be this will be really nice for us to look at. Don't mind what I've just done. I was just fixing something. Okay, I was just fixing these tags, but I know they're messed up somewhere. So the learning objectives of this, we're going to learn to connect to the cloud-based GPU environments. That's Google Colab T4. And then orchestrate automated data acquisition using Google Colab. We're going to understand how to perform exploratory data analysis, which we've been looking at in the previous weeks, find the physical sensor correlations, and then also to compare traditional machine learning using random forest versus the deep learning using neural networks. Then also to generate the industrial grade reports and visual dashboards. That's basically visualization. So it's a lot, but this video will be available for you to review. I know there are so many videos pending, but they'll be up. So the technical stack that falls in here, Google Colab, CPU, GPU, data source is going to be Kagona crop recommendation dataset. You can even check it. And then processing, we're going to use pandas, NumPy, scikit-learn, which is present in Google Colab. Then for deep learning, we're going to use TensorFlow, Keras, and then we're going to run on NVIDIA T4 GPU. And then visualizations, we're going to use the Seaborn, and then we're going to use the Matplotlib. So that's the description for that. Okay, so phase 1, environment and data triage. So we will verify our cloud GPU connection and perform an automated pull of the data set. That is basically importing data from Kagona and bringing it out of. Then we shall perform a clinical, sorry about that. Okay, just very small. All right. Okay, so what did I do? So we shall perform where is it? A clinical health check on the data to ensure there are no missing sensor readings. And then phase 2, let me ignore that, by the way. We shall do the visual intelligence. We shall generate dashboards to visualize the signature of coffee. We shall analyze the rainfall thresholds, comparing water requirements across Ugandan regions. We shall do soil acidity check, that is checking the pH, understanding the chemical sweet spots for coffee, then correlation matrix, understanding how nitrogen, phosphorus, and potassium interact. Then phase three, we shall build the AI brain. We shall implement a dual model approach where we shall use the random forest. We shall have a pan of 100 decision trees to provide stable crop logic. And also we shall talk about artificial neural networks, where we shall be discussing a deep learning structure to capture the non-linear patterns using the GPU acceleration. And phase four, the industrial evaluation and deployment, we shall evaluate our models using the confusion matrix and feature importance analysis. And then finally, we shall simulate a real farm in Masaka, Mbale, to see Masaka or Mbale. These are different regions, honestly, to see if our AI can accurately recommend the crop based on the live sensor inputs. Now, sensor inputs, this is basically data. If you want to find out the soil pH and etc., you're going to use a sensor that you push down in the soil, like, do you know the stick that measures the measures the volume of let's say fuel. If a truck brings fuel at the fuel station, they put it in that big drum, and then there's a stick that is inserted to measure, how much fuel has been brought. So that's almost the same stick you push in the soil. Of course, the one for the soil is a bit smaller than that. So make sure that as you access Google Colab, you are logged into your favorite Gmail account, because some of the things get saved within your Google Drive. And then make sure you have access to Kaggle accounts so that you can access the dataset API. And then, yeah, I think that's it. Yeah, I can see Rachel is already excited. Yeah, already excited. So we're gonna need to access the data. Going to need to access the data so that we can get to start immediately. So you could try to search for that data on Kaggle. I was doing a random check before the call. In most cases, I think about this data like a few minutes before the call. That's when I figure I think which data should we use. Because at first, I think the previous weeks we were using, I think, like data to do with with machinery that had a lot of physics, which I felt people cannot relate with. Well, last week we also held some data for health, which was good. People loved it. At least the feedback was good using that data, because people can really relate. And I think we voted which data should we use, and people gave suggestions. Can we do data to do with the heart? Can we do data to do with, this and that? So that was good. That was good. And I think that's how it should be. We should be able to discuss and agree on the data that we should use. Okay, so let me share a simple link to this data so that I save a lot of time. Yeah, where is the chart? Okay. Copy meeting link. No. Okay, I'm trying to see how I can get to share this. Okay. Yeah, right here. I've seen it. Okay. You must have seen a link drop into the chat. So that's the link to the data. Let me stop this share so that yeah. So clicking on the link, let me share again the screen so that we can all look at the data. So there we go. So here is the data that we are going to be using today. Crop recommendation data sets. They're saying maximize agricultural yield by recommending appropriate crops. This is an amazing image they have right here, because it clearly shows you. But you get to think about it. If let's say family within the Mukono region or Western region or somewhere think about the families you've seen in many years. If they've been growing beans and maize on their land up to today, that's what they are growing. Even though things die, fail, they just keep on growing there. They have no idea that because of climate change, soils tend to shift, whereby if you used to grow maize and things and the production is successful, today it's gonna fail. They have no idea. They just keep on growing and they're like, oh, this season things didn't work out the way they did. They try to change the seeds to some other seeds, but they are forgetting that they need a data scientist to help them. So let's look deeper into this data. The context, they're saying precision agriculture is in trend nowadays. It helps the farmers to get informed decisions about the farming strategy. Here, I present you a data set which would allow the users to build a predictive model to recommend the most suitable crops to grow in a particular farm based on various parameters. Remember what I told you, before you use data from Kaggle, you need to understand the data. Do not use data you do not understand. And you need to know the intent. Why did someone upload that particular data set? You're presented with a context of why the data set was uploaded. And it's right here to build a predictive model to recommend the most suitable crops to grow in a particular farm based on various parameters. So they're saying that this data set was built by augmenting data sets of rainfall, climate, and fertilizer data available for India. Now, this is data for India, but of course, for learning purposes, you can use it and then you can collect your own data in Uganda. So there is augmentation of data sets of rainfall. So that means there is rainfall data, climate, and fertilizer data. If you look at the data fields, we are seeing ratio of nitrogen content in the soil, represented by N, ratio of phosphorus content in the soil, represented by P, ratio of potassium content in the soil, represented by K, temperature in degrees Celsius, humidity in percentage form, then pH value of the soil, and then the rainfall in that. Okay. So if you look at some of the different visualizations done by some of um, the previous analysis, looking at him here, anyway, you can just click here for basic viewing, of what has been done by this particular fellow, and that's it. So that's it. You can read further if you want to, but I think that's enough for me to know why that data was pulled there. Okay, so remember what I told you. You can look into here to see how you can access the API. So you can see that you can pull this data directly, over here using that, or you can simply get this code where you import the Cargo Hub. From the Cargo Hub, import Cargo Dataset Adapter, and then you can get that data, and then you can print out the first rows, 5 rows of that particular data. So that is for the first part of accessing the data. Yeah. Okay, so the second part, I believe now you know where the data is to search Google Colab. Google Colab. So you should see collab.research.google.com. So this is something you should see the moment you come onto here. You should see such a thing. Yeah, lots of stuff here. Now I need to delete all this stuff, because I was using it to teach in the old days. I want to clear the history. Yeah, I don't need the history. I sure you want to delete all 0 items. I didn't even select an item. There is nothing. Okay, so hope this is where we are, and I'm gonna speak about a lot of things in here. Nice. Okay, you click on new notebook. Most of you know how to use Google Colab. It's been many years. I've not used Google Colab. When did I last use it? I think I last used it on the project I had with GIZ. That's the last project, which was a data science project where I was a lead in that particular project. Um, so I'm giving a minute to reach here. Someone say, there I am. Yeah. Okay. Okay. So let's go. All right. So don't mind what I've clicked. So I was just wanting to show you that you can click that if you want to show tables of contents and all that. If you want to add an AI prompt cell, but we don't need that for today. Ignore that. Simply click over here so that you can name your file. Just click to it and we can rename it. What should I call it? I'll call it farmers soil predictor, or predictor soil predictor. And I don't know how to write the word prediction, so just leave it like predictor. I don't know. Let me leave it the way it is. So ignore that. Okay, so let's move on. I'll click. So if you want to switch to the cloud CPU GPUs, you're gonna have to click on runtime, and then you click on change runtime. Right. So if you click that, then you're going to access this. You're gonna access this. So if you're working in Julia, you're working in R, so you can make those switch as you wish, depending on the language you intend to use, the runtime type. So over here, we're going to switch to T4 GPU. So from CPU to GPU, right there. So the moment you click that, you've activated the hardware accelerator and you're going to be working in the cloud. You will not use your processor in any way. Yeah. Okay, so before I leave that screen, I'd love to basically speak about a few things. Now, CPUs handle sequential tasks like data cleaning and preprocessing. These are simple tasks, and that's why a CPU can easily handle that. But then the GPUs do execute massive power computations, more than one computation, and that's the power computation. You have more than one computation going on. And if you look at the field of machine learning and artificial intelligence, the CPUs manage system logic and orchestration. But then when you look at the GPUs, they accelerate training and that inference of models, things like the deep learning, things like the LLMs. Now, this processing of vast amounts of data simultaneously can only be handled by the GPUs. So if you look at the CPU, in your schools, you are told that the CPU is simply the central processing unit, and that is true. They are basically built with a few highly powerful cores. You might have heard about Core 4, Core 5, Core 3. As you're growing up, now these cores are designed for sequential processing and logic, and they simply act as the brain of the computer, and they do manage that operating system. So if you're doing the initial data exploration, they can handle that. If you're doing the data preparation pipelines, they can simply handle that. But then when you look at the GPU, this is simply called the graphics. It's called the graphics processing unit. And there's a reason why it's a graphics processing unit, because it contains thousands of smaller specialized cores. Now, this was originally designed or meant for rendering graphics. So if someone is doing something like robotics, or is doing architecture designs, and then is doing the rendering of those different graphics, it was designed for that, you know. But then later there was a realization that their power architecture makes them the gold standard for matrix multiplication. That is the mathematical foundation of the neural networks that you've heard about, or if someone has mentioned deep learning, if that is easy for you to pick up that. Now, what is their contribution to the field of data science or machine learning or AI? Now, in data science, we have things like data wrangling. These are some of the standard practices that we do have: handling tabular data, and also the small scale statistical modeling. You know, these are basically best for CPU, like I mentioned. But then when you shift to a little bit of traditional machine learning, you can also do the random forest. You can do vector machines as well. And most of these rely on things like the decision trees that, you know, make them a little bit largely for the CPU bound, basically. Looking at deep learning and AI, apart from what people say or think when they speak about AI, here we are looking at training complex neural networks, training the convolutional neural networks, training the transformers, the LLMs. This practice involves billions of parameters and matrix operations. I wish I had a session with everybody available physically. I would take you through how to develop the entire convolutional neural network, and then you see that that vector multiplication that happens. It's just crazy and ridiculous. So if you look at the GPUs, they drastically reduce training times. So if it's going to take you over a week it brings it to hours, you know, processing data concurrently. And also, once a model is trained, running it to make real-time predictions or processing prompts relies heavily on GPUs throughout, and there is low latency memory in that. So there is a tendency of these two working together. And if you look at in the modern data science, professionals, they love the use of what we call the heterogeneous computing approach, where the CPU handles data loading, preprocessing, and model initialization, and then passes the computing there, heavy matrix multiplication, directly to the GPU. And also, when you look at the modern deep learning, there is a consensus among machine learning practitioners whereby, you know, there is a dedicated kind of the NVIDIA GPU, like the one we're going to use, which has that robust VRAM, if you've heard about the VRAM capacity, which has about, let's say, 10 GB or 24 GB plus, you know, and that is meant for training or fine-tuning models locally. So we are going to be using the cloud-based GPU platforms because they offer that accessible workaround for the low budget operations. As you may know that some of you, your computers are a little bit weak. Yeah. Okay. So now I think I've spoken about the GPU and the CPU, unless if there is something specific, but I feel that should be enough for that. So that we can move on straight to what we're supposed to look at. So now simply from here, you can simply click save, and then you're good to go. If you click save, you are good to go. You've connected to it. There are other things you can actually do or play around here in Google Colab that you can explore in your free time. So as you can see the T4 right here. So if you click connect, you can see that connection. But of course, if you're doing simple machine learning, really, if you're doing simple data, analysis, you don't need a T4. This is highly powerful, really. You don't need it, because now, look, if you look at that, I've connected. It shows you the RAM, it shows you the disk over there. You can see. So we've connected to Python 3 Google Compute Engine backend, the GPU. So it's better to use it when you need it. Maybe the question would be, when do I need it? When do I not need it? And that's what I explained in the first step. So I hope we are the same level. Someone is saying that I've muted. Is it true?
No, this
We are
time
hearing you.
No. Yeah, I think someone is saying that I muted them. What is wrong? Joash, when you need to talk, raise up your hand. This is an interesting statement, and he has spoken via the what? That's an interesting one. Anyway, okay, copy scratch at form. Just looking at the different functions. So add a form, default text. Okay, so there are so many different things we can do here. I'm trying to explore any new things, restarting sessions, just like it is in the other area. I think it's the other person you muted when the session began. Yeah, that was the person. Code snippets. So if you need code snippets, find and replace. Data inspector, secrets, files. If you click files, kind of shows you the files, sample data. There is some sample data in here, California housing, etc., etc., but I don't need that. I'm just trying to look at some of the few things in here. Data Explorer. So if you want to explore data, fraud, game sales, there's a lot of data in here. These are cargo competitions that you can connect to in dataset, so you can search. But here, do I have anything on there? Can make a search, I think. Oh, that's different on there. You can make a search of data right there. So file, this is located drive. So if you want to locate a drive, I don't want to do that. Opening the playground. Okay. Download. So it's good to familiarize yourself with a lot of those. So I'll stop there. So I'll just come and copy this. I love having things put up properly. Okay, explain port the phone. Editor settings. Okay, fine. Okay, fine. All right. So let's begin on this. You can explore it further if you wish to. You can also enable collaboration. I think it's this. So the moment you click on share, you're able to look up people, change anyone with a link if you want to, then you can connect and you work together if you want to, so that's that button if you want to work together. Okay, so let's start. So to begin, we've set up our GPU, everything is okay. So we're going to prepare our tools and then we're going to verify if Google has given us the T4 GPU. I think it has. We have verified that moving forward. Okay, so I love running with comments in what I do. So we're gonna start with install necessary. Oh my God, how am I writing this? Necessary. Okay, we're gonna start with install necessary libraries. Now this is a little bit different from Jupyter. That here, for example, you want to install if you want to do a pip install cargo hub, you can do it directly here, you know. Could you please pardon on how we verify it? Okay, I'm going to speak about that. So here you can do it directly here if you wanna install such a thing. Around here, this is where we verified from. You just simply click and then it will connect. The moment you come to runtime and then runtime type and then you click T4 and you save, it will bring it here. You click connect and then you'll be able to connect. Yeah, so that's what you do. Okay, yeah, I was looking for the text feature. So now I'll come back up here and I'll click this text feature. Yeah, now what happens in most cases, now moving up is right here. You discover most of these things by doing. The more you do, the more you discover a lot of this. So this is the text feature. I was kind of looking for it, but I couldn't find it. So now you can put some of your text if you want to, so that you give context to what you're doing. You make it, you make whoever is getting to look at it understand what you're doing. So just putting this in here, make it look a little bit the way you wish to. Okay, I don't know. That's much better. Yeah, that's much better. Hmm. Yeah, should be okay. Okay, so you can see that looks better. Yeah. You guys can try to do that, but I didn't come here to edit text, but just to show you how you make it readable for others to basically understand what to do. So now I don't need this section. I need only that section. Okay, so going to the next. Okay. So we import the libraries. So these libraries, I can tell them the workforce because if you don't have the libraries, then it's gonna be crazy for you. So I'll call the libraries the workforce. Okay, so import the libraries. So import the libraries. I need to check. Um, I need to check. Okay, I just wanted to know how many people we have in the call today. I need to check to change the layout so that I'm able to see you guys on the side. Where is this? It's right here. Ah, yeah, yeah, side by side. Nice. Okay. Um, okay, so you're able to maximize the shared content if you look into WebEx up in the corner somewhere, you'll be able to maximize that, you know. You'll be able to see and maximize that. Yeah. So that things come on screen clearly for you and things are well put. Okay, nice. So we can proceed. I've been able to verify 24 people. Okay. Okay. Right. So let's proceed. Sorry, I keep on checking a few people on the phone. There are people who love texting me when I'm busy. I don't know why, you know. So okay, so this is what we're gonna need. So we need to import Cargo Hub. Remember, this is where our data is coming from. Now, I believe people will not have issues with this. You know, we import that. So even if I click right here on importation, you see that tick on the side? It shows that data has been imported. Then we need to import, remember we spoke about we need pandas. This is our Excel as PD. It does everything we need. Even if I click that, it will share tick that, yeah, that is captured. It's not mandatory for you to click on the side, but I love doing it to make sure I don't have any error in something I've just done and to help me move on well. Okay. So for those doing internship tomorrow, when I'm physical tomorrow, I'm going to be reviewing your logbooks and everything one by one and see the progress you've made with what we are doing, this work and your project. I'll be reviewing and then we shall be going through everything. That will work that way. And for the online people, I think we shall set up a link and then we see. Yes, Vanessa, you have your hand up.
It's okay. It's okay.
Are you sure, Vani? It's okay?
Yes,
All right,
for
if you say so.
online students.
Okay, yeah, we shall set up a link really because I need to get things done, especially the data science team. I need to work on your marks. So make sure your logbooks are fully filled up. We're on week 6. I expect a
Okay.
lot of things in there and things have to be technical. Things we've covered completely, guys. Okay,
Yes,
we
sir.
shall see what to do. All right. So we want to bring PyPlot as PLT. So I'll simply click that. That is to help us with the plottings that we hope to do. Then we want to import the Seaborn. We want to import the Seaborn as I think SNS. Yeah. What else? We want to import OS. It's already there. Let me try to click on the side and make sure I'm not getting things wrong here. Okay, nice. Later, we want to do some machine learning. So we want to import some TensorFlow. I wish I get enough time to take you guys through TensorFlow. TF. Then from IPython, the display, yeah, import. Now, the beauty with Google Colab, it helps you finish things. File link, yeah. All right, nice. Yeah, we are safe with the importation. We are safe with the importation. Page. So we are going to the second part of this. I said we're gonna move a little bit faster than how we were going. All right. So number 3 of what I want us to do is you can as well do. Let's check for the GPU. And this GPU here is called it's the industrial engine. It's the industrial engine. Okay. So we need the local, we need the local variable to device name. So we're gonna use TensorFlow, the tests access to GPU. Now the beauty with these commands, they are the same everywhere. They are the same. So this is a function. So you can use them and reuse them and reuse them and reuse them. Okay, so we want to say that if the device name is not equal, the not equal is written like this, to device GPU, what should happen? Then we want to print something. Want to print GPU non-found. So what should happen? Someone needs to go to runtime. What we did, go to runtime and change runtime type. What? I want to change it to T4 GPU. Nice. Okay. So what if your GPU is okay? That means if your GPU is okay, then I think you want to have a different print statement. So we want to print, we can use the F function for printing success. We connected to the GPU. So we can say T4 GPU is active. But you can pick up the device name. Nice. Try to run this. Are you guys able to get that same message? You can tell me. That's how you verify. Sir, what is the use of from my Python display import file link? Nice question. Right there. So you can put your questions. I forgot. The moment you type your question in the chat, I'll be able to see it immediately. So feel free to use that chat forum so that you can put your questions there. Then I'll respond. Okay, so you're asking that what's the use of this from ipython.display import that. So this basically allows you to create that kind of clickable hyperlink. If for example, you're using a Jupyter Notebook, then you'll be able to bring in that clickable link within your notebook. It is very common with data scientists. They actually use it a lot. If you are working with a lot of files, these files, if they cannot display as raw text in the notebook interface, then it's better to have that clickable link. So that's why we say that from python.display import file link. So it helps you to have a file link that represent that file that cannot open within the notebook, but someone can click it and then is able to access it. Yeah, so sometimes you can be working on a project where your files are, let's say, on your local server or something, or any remote server, and you basically need that FTP client, eh, but then you don't have to use the FTP client, Yeah, so you can easily download the files directly from any remote server without you needing to use any FTP client or cloud storage whatsoever. And it also helps you to avoid overthrowing a lot of data sets within the notebook. And it makes it easy as well to handle exports, basically, because it offers that immediate download link, for the users that are trying to read or users that are trying to evaluate your notebook. So they easily get the link, click on it, and then see things instead of overwhelming the notebook. Yeah, so basically that's how I can explain that. But it's very, very common and it's a very good practice in the data science field. Okay, I hope you all, yeah, I'm moving on. Okay, what are we supposed to do next? We're supposed to go to number 4, where we create a folder for the industrial. How do they write? Industrial reports. Okay, so we want to do this. Okay, so we can say that if not os.path.
Hello.
Hi. Um,
Mm, I've got an issue. I don't know why I'm getting this error that no module named IPython.
okay, so we're gonna need to look at your screen.
Okay.
Are you able to share your screen in the next second?
Yeah, let me try.
Okay, just give me a second. I see whether this code I'm trying to works. Exports, then I share you the. Okay, if not, this path. Okay, and the second. No, okay. Wanna make the directory? Yeah, make those. So the directory I wanna make is exports directory. Okay. See where this is gonna work for me. Nice. Okay, so this is where I stop the share and then we look at your screen. Please show us what you have. Okay, someone else say, does it need to be installed first? Python.display. No, you don't need to install it first. It will work. It will work. So the moment you say from IPython.display, IPython is already an inbuilt library within, so it should work automatically. Help me make that I capital, the IPython, make it capital. That I right there. Yeah, make it capital. IPython.display. Import file link. Help me make that file capital, the first letter for file link. Okay, file link. IPython import. Try to run the cell. Um, did you run the cell? No, not error. IPython. Okay. Okay, let's do this together, by the way. I was going to give you the solution right away. So help me copy module not found error, no module named IPython, and then you go to
Tell P,
the
P,
tab.
P is also a capital. P is also capital. IP.
Yeah, put P, make P the capital right there. Someone has been very observant. Nice. So finally, Joseph, I was going to disturb you. So you run that cell again and it should work. Okay, so you can see the sensitivity right there that's acted on you. But that was a very good one for people to know. Okay, nice. And the simple way as well, sometimes you just simply copy that, put it in Google, ask it, hey, what am I getting wrong? And Google will tell you, hey, here you're supposed to make it capital. And that's what was going to happen. Okay, so we are here. We are creating a folder for the industrial reports. So you can check, you can do that. Let's try to. Okay, if I locate in the drive, I should see something like farmers. You can see right here, farmers, soil. That's where the project is. Okay. Oh, you're gonna have to move faster than that. There you go. So you can see. That's where the project is. Yeah. So it's right here on my drive. It's located right there on the drive. If I come back on drive over here, you can see Colab notebooks. That's where your work would be or is. So you click on that, you can see a lot of work right here. So hope that is clear on how to locate your files. I'll go away from here. I'll come back here. Okay. Let's proceed. Okay. So I don't know how far you guys have reached with your projects. I'm teaching you a lot of new things every day. You need to see what to do. Okay. If you look down here, you can still see T4 runtime. You can change the runtime from here. So you can see a lot of things right there. Focus on the last run cell, so you can click here as well. Anyway, lots of things interesting here. If you need a terminal, you can click and you get the terminal right on the side. Variable, click on the variable, then you're able to see the device name is a string and etc. Yeah. So like I told you, using Google Colab or using tools, it's all about using it every day and discovering different things as you run. You can see that. So lots of beautiful things in there. Okay. What are we doing next? We've handled the exports. I wanted to talk about something simple right here as you move on. So these pandas, the pandas right here, it is simply for data tables when you're handling data tables. Yes, Rachel, I think you've raised up your hand.
So when I try to run that code for checking the GPU, the industrial engine, it's showing me that there is an error with the syntax for the else part.
The else, yes, that's interesting. It's because you didn't put it in the right position. Can you share your screen so that we can learn all together how to fix? Please share. Let's fix that together.
All right.
Yeah. Imagine we keep inviting people who are doing internship elsewhere to join us, and for them, they never invite us for their sessions.
Are you able to see my screen?
Oh, I can see it right here. Yeah, that's exactly what I've spoken about. So what do you see? What do you see right there?
I don't know if I should extend it behind. But this
Can someone
I
tell
don't
what's
know.
missing? Yeah, you're right there. You're actually in the right answer, but there's a way it's supposed to be done. Let me see whether someone is able to see. Anyone on the call? What do you see?
I think the indentation.
Okay. Mm-hmm. Do you see where your marker is on else and those two dots that you have?
Yeah.
Now, those two dots are supposed to be at the end of the T4 GPU brackets. It's supposed to be at the end so that your else positions itself where it should be.
Okay.
Yeah, can you put them there? Now click enter. No, you're supposed to click enter so that you go to the next cell.
I get it.
Are you sure? Did it come the way it should come?
So are they
Okay,
supposed to be here at else?
now the else has to be on the same line with the if.
Yeah,
Because
that I get
it's
it.
it's an alternative.
Yes, please. So what I'm trying to ask is, am I supposed to have these columns here on the else part?
Yes, you're supposed to. That's conditional. You're
Oh, all
supposed to.
right. So
Yeah, you
after
actually,
pressing the colons here on the T4 GPU part, then I press enter, right?
yeah, but then move for me the else behind on the same line of the if.
Okay.
Move it behind. Okay, now you can see those have disappeared, right?
Yeah, I get it now.
Okay, now you can run.
Still bringing an error.
What is the
GPU
error?
device. Let me see. Invalid syntax.
So what's the fix?
Let me see.
There are some people who are not doing internship asking me for the recording. Can you imagine? We are doing this together. What do you see? Okay, 2 people raised their hand. Could you speak? Okay, so click at the beginning of the print and move it back to the 2 dots above, as if it's one statement. Just click back. Now
Like
click
that?
enter. Yeah, now click enter for it to go down. Okay.
I run.
Okay, now run again.
Still having the same issue.
Oh, you have invalid syntax. Sorry, it is a syntax.
There is a colon at the very end of the print line. I
Yes,
think you need to remove those.
there
That
is
colon.
something at the end.
Yeah.
This one.
Yeah.
Yeah.
All right. Okay, thank you.
So I need to be very observant.
Excuse me, sir.
Yes, please.
For me, I'm getting an error on the tensor flow.
Okay,
So
can you
I don't
share
know.
screen?
Don't know. Okay.
Please share your screen. Okay. I didn't know that there are people who are doing internship with us, but they haven't yet joined, by the way. And we are about to end. Someone just texted me. Yeah. Because if you're affected by the fee, then you could simply look for another place where maybe they don't charge anything. For us, we charge because you consider resources we access. Some of them we pay for them. Share your screen, please. Okay, nice.
So you can see the screen?
Yeah, I can see the screen properly.
Yeah.
Okay, the first issue you have cargo hub. They're telling you that it's an known word.
Yeah, here.
That is the first. Yeah, the moment you see those things written below your text, then you know something is wrong. So the first importation, import cargo hub. They're saying, we don't know the cargo hub that you're talking about. Do you know why? There is a text,
No.
there is a pip install cargo hub that I did above that area. Do you have it?
Oh,
The pip install
no.
cargo hub? Do you have it somewhere?
No, I did do that.
Yeah, that's why it's screaming for you. You need to have it. Let me send it to you in the chat so that you can simply copy and paste it when you're still on. Where is the chart? Okay, right. All right, copy that and throw it in and run again there so that we see. I've sent it. Just keep the screen. Where are you sharing from? I think you're sharing us something different now. Just share the entire screen so that we focus. Did you see the link?
No, not yet.
I sent it
Is
in
it
the
from the
chat.
WhatsApp, sir?
No, not WhatsApp. We're on this platform. Checking the messages. Ready, set, messages to everyone will be saved after the meeting. Close that.
Close this.
Mhm.
Yeah.
How come you're not seeing the messages? Write
I can't
something
see
in the
them.
messages. Type something in the messages. I can see your message. It's okay. Let me try to simply reply your message.
Okay.
Store the thread. And also your message has disappeared after you sent it to me. Do you notice
I
that?
can't even see it. I can't even see it here that I've sent a message.
That's fishy. That's interesting. Okay, you go and we type it together. It's fine.
Okay.
Yeah.
Yeah.
Okay. Are you doing internship with us?
Yes.
That's surprising, Alan. Okay, you do remove that hash. Yeah. Now you do pip install cargo hub. Vanessa is laughing at that. Yeah, because I don't know why. Install cargo hub. But I know my system only flags the people that I just invite. Cargo hub. Okay.
No, just because I'm using another email address.
Yeah, I should be. I think so. Okay. Can you put at the beginning before pip put that they call it apostrophe? I think this is where the English we started to make sense.
An
Try to remember.
exclamation mark.
An exclamation mark. This one,
I
eh?
think it's exclamation. Yeah. Something of a kind. Try to run if you've written everything well.
Them they calculate the salary, they look at the employer's salary, they build the as
Maybe
work,
process using.
they compute the benefit.
Alan, you use the exclamation.
Yeah.
Yeah, I've used an exclamation mark here. Isn't it this?
It is showing as if it's a slash. Exclamation, that thing which drops down with a point down.
Yeah, this one, right? Let me just put
Yeah.
a space so that you can see it well, right? And it's saying enable process using this.
Okay. You use that. You put a percentage at the beginning.
And I remove the exclamation mark.
Yeah. Yeah. Remove it. Run that. Okay. It's not worked for you. Okay. If you want it not to bring those things down, you can put quiet, dash quiet at the end, so that it doesn't at the end. But it says space. You put space dash quiet. Oh, I didn't know that you're working within Visual Studio Code, VS Code.
I'm using Visual Studio.
Why don't you use Google Colab? Because that's what we're doing today.
Okay, let me go there.
Yeah, you need to be there. All along, I didn't know. I just realized. We wouldn't be hustling like this, please. You need to go there. Okay, let's move on. Yeah. Okay, I have another hand up. You can lower your hand, Alan. I think I fixed your problem. Rachel?
Okay, thank you.
Oh, Rachel, did you just put your hand down? Okay.
Oh, I just forgot to lower it. That's why it was still up.
Okay, nice. Okay. Oh, let's move on. Okay, so back here, you guys make sure your code is as neat as my code. I love the way my code looks. It's good. Yeah, motivates me. All right, where are we, Magda? So basically, before we left off, I was talking about the pandas, and I was saying that pandas, they basically handle the data tables. Like I say, this is the Excel for machine learning, for AI and data science. And for people that love makeup, especially the ladies, this is your thing, Seaborn. So Seaborn is for beauty, basically, for beauty. And for people who love to think a lot, you're right here, TensorFlow. TensorFlow is for brain. That is where the deep learning happens, the TensorFlow. So the GPU doesn't just make the computer faster. It actually allows us to do thousands of mathematical matrix multiplications at the same time, which is how neural networks do think. So let's move to the next part. Let me have a text right here. So we're gonna move to, should I call it step 2? Did I have step 1? I'm gonna call it data acquisition. Okay, let's call this state automated data. Okay, so I can say we are pulling the recommendation. Pulling the recommendation data sets. And we say that this contains the soil chemistry. Do they write chemistry like that? Data for 22 different crops. So from today onwards, just use Google Colab, different crops, because you reach a point and you get stuck with your computer. 2 different crops, including coffee. You can pass whatever you're doing to GitHub, and you're able to access it from anywhere. Okay, so that's what we have right there. That's enough. That's good. Okay. Okay, let's go to the next. See how my code looks like. I think I love the way it looks like. Yeah. Step 2. Okay, so now we are going to the next step. So what are we gonna do first? We need to let's run a print, a simple print right here. Download dataset from Kagona. It's just a print statement. It doesn't mean anything. If you click on it, it will just show that. Okay, so now we need to specify. Let me put a comment here. And I'll say using Cargo app to pull the specific agriculture data set. Okay, so if you want to pull this data, then we need to start by specifying the local variable where we want the data to be stored. So we want to have it in the path, and we want to get it from the Cargo Hub like we were doing before. And what we want to do is to download it. datasets to download. Okay, so we can get this. Okay, there we go. Google Hub has no attributes. Datasets. It's fine. Dataset. Don't worry. I know how to deal with you. Okay, there we go. We're good. So my data is downloading. It's on 100%. That's downloaded already. Okay, now we want to do something interesting, which I want to call path management. Path management. So I want to define the CSV path. So I want to do path. Like I told you that you don't have to master these codes. You just need to know the procedure and what you need. And then you can simply use these codes and manipulate them the way you want on any data. Okay, crop recommendation. Let's see. Okay. I'm just trying out something. So use data frame just to pd dot read. Then you put the CSV path, right? Yeah. CSV path. There you go. Okay, so lastly here, I want to run a print. Okay, so we need to swim samples. The field. Okay. Working well. Okay. Yeah, stop head. All right, so this is where we are. Guys, you need to have very neat code. Very, very neat code. Very, very neat code. And if you can explain it, then you're good to go. So that's what you're supposed to have. Give me a minute to get that out. So some email to me.
I'm
So
getting an errors here.
you're getting some errors. Okay. Let me get you to share your screen. Just give it a few seconds and people copy what I have and then. People are putting up a meeting. Okay, so you can share your screen so that we can diagnose that. I was responding to some email. Mhm.
Right here, it doesn't fully download. I think that is what caused the errors. I don't know.
Oh, okay. Does it try to download?
Yeah, I run it here and there is
Ah, you've done the
issue.
prints. Yeah, you see the path, cargo herb dataset, download, that's okay. Then you pull the data
I
using
don't know what the
Colab
hell it is.
cache for fast access to
I don't
the.
know what it is.
It doesn't download for you. I'm not seeing the download. That's not the
Yeah.
cell to run. Let's look. Let's look at that comment. Yeah, rerun it and we see.
Just come back with the same.
Okay, let me see. Hmm. Let's wait for that error. Yeah, it shows like you have the cache memory enabled, and that's where it stops.
Yeah.
Yeah, you copy that link of using Colab cache for fast access, and we put it in the browser and we put disable, and we see whether that can be disabled.
In a browser?
Yeah, anywhere, and put disable. Just paste it there and put at the end disable. Yeah, copy that.
This line.
Yeah, just
both?
copy using this down here. There is a copy.
Oh, okay.
There's a copy.
So
Yeah,
this line.
use that. Yeah. Mm.
So what do you want to replace it?
Just replace it with that line of that path is path equals cargo. Just replace with that. Yeah, just replace the entire cargo path thing.
The entire
No, the entire line. Yes, everything.
line. Okay. The right?
Yeah, run again. Yeah, run again. Okay, let's see. Load dataset crop. Download mod. First download. Okay, dataset. Okay, I'm gonna teach you more troubleshooting. So what you're gonna do, copy everything in the error and you go back to the same window where you got that code. Just copy everything. Paste it there. Nice. Go back to your code. Oh, you already ran.
Oh,
Okay, it's fine. It's
it's
fine. It's fine. You scroll and I see the solution they're giving you.
Oh.
Yeah, there's something else you're supposed to add. First clear this other test you've done. Okay, now you go to cargo platform. Just just teaching you a few techniques you can play around with. How come your dataset doesn't? I want to add the exact dataset. You go to download, where is download?
You need to click download.
Yeah, copy that. Copy that. Just click the copy area for that. Yeah. And then you've copied it, take it to the other Google place.
Here.
Yeah, yeah.
Hmm.
Paste it there. Run and we see whether it corrects you. Go extremely down so that we see. Okay, it does up. Go up. There. Copy that. Yeah, now take it there.
Copy it, paste it here.
Yeah, replace everything. Yeah, there. From there. Okay, wait, let's see. The only replacement from the code I gave you was the first download equals to true. So you run. That is the only change. Okay, it's only printing two things. First, refresh download. There is something else it provided you in the browser. You go to it, you go back to the browser, down. It gave you that bash. Remove that, yeah. Copy that, yeah. Okay, now go above, create a cell and move it above that.
Above this one.
Yeah.
Hmm.
Go on the right hand side and move it above. Okay, fine. It's okay, whatever works faster for you. Okay, now paste it there. Yeah, run that. Okay, now your code should work. Run. You may need to refresh.
I have this
You may
import
need.
up there.
You're gonna need to replace something. You're going to, let me see from where, restart session, clear all outputs. Okay, click on run all. Where is run all? On that drop down.
Oh.
Clear all outputs. And then click it again. And then restart session and run all.
That's weird.
It's fine. You move to the next code. So, you need to move to the next codes to check whether you have that data. You might be having it. Yeah, you write the next cells of code, the ones I've written, you'll tell me whether you have it. You can stop the share.
Okay. Okay.
So you should write, do this, and then do this. So I'll throw this next part in the chat to give you a bit of speed. So I've sent that next part in the chat and also this part in the chat so that we can move on. Okay, I've sent those two, this and this, into the chat so that we can move on. Okay, so when you look at this data here, okay, just wanted to make it a little bit interactive. When you look at this data here, over here, the N, we have the NPK. So remember, the N represents nitrogen, the P represents phosphorus, and the K represents potassium. That's from chemistry. And these are the three main foods for the plant. You know, this is what the plant needs in the soil for things to happen. Then we are having the pH over here. So this is the acidity of the soil, you know. And you know that Ugandan coffee thrives at the pH 5.5 to 6.5. That's Ugandan pH. So I can see the pH is great. Then we're having rainfall over here. So rainfall is measured in, is it millimeter? Vital for the coffee flowering season. So that is rainfall. Okay. Yeah, they're saying like what you see, visit the data table to learn more about interactive development. So what the hell it is. Now, these are basically links to teach you more. I don't want to learn more. I think I've learned enough. If you click this, I love trying out things. So if it brings anything I don't want, I kick it. Okay, Gemini, analyzing data. I don't think I need that. Okay, so let's go to step 3. So step 3, we want to do some bit of deep visual analysis. Deep visual analysis. Okay. Deep visual analysis. I'll call this something interesting. The coffee signature. So I'm gonna call things interesting names. So before we use AI, we must do what? We must first see the data that we want to use AI on. And then we want to know what makes coffee different from maize. Hey, All right. So this is where we get to use the beauty, the CNS, the seaborn. This is where we bring in the seaborn. So this is where we do CNS dot set. I say this one deals with the beauty. So we want to set the theme and we want to define the style. So this style should be white grid, maybe. I'll set it to white grid. Okay. So we do the plt.figure. So I want to define the figure size. So I want to give it 15 and so I want to give it 15 and maybe 6. 15 and 6. Yeah, so 15 and 6 is very okay.
So what do they mean? Height and width or width and height?
Let's look at the output and then I explain that to you. Okay, so this is what we have. Okay, so can you have that? Um, let's move to the next. Okay, so in development, even if it's web, so the moment you define the figure size, the starting area is always the width and the second area is always the height. So it's basically more of like a rectangle in most cases. Yeah, so it's always more like a rectangle for that. Okay. And I think it's referred to as more like a tuple, something like that. Tuple, something like that. Okay, that is very okay. So I'll use different cells. I'll come up with another cell here so that I don't overwhelm everything. So here we can do a box plots of rainfall. So we want to identify which crops are thirsty. So fine. Which crops thirsty? How do they write about thirsty? Thirsty. Okay. So we are going to use in colors, we have something called a hue. So we shall, how do they write? Assign. We shall assign hue to avoid the warnings, some warnings. So we're gonna assign that. Okay. Let's move. So let's do the plotting. So we're gonna do the SNS. We define the beauty. So we're gonna do the box plot, like we've said. So when you look at the X, we're gonna label the X-axis. So we wanna have a label on that. And also we want to label the Y-axis of the plot, as you know how that is done. So let's give this rainfall. Okay, data frame. So we're gonna do the hue, level. There's a certain error. If we get it, I'll show it to you why I'm using the hue. Palettes. So the palette, we wanna use the Viridis. You can read about these palettes. You just put it in Google and then you read about it. And then, do we need a legend here? No. Keep it as false. Right now. Okay, so, oh God. So every time I write code, I love to check whether anything is wrong. Okay, could not interpret the label for X. Yeah, you can see that. So I didn't write it correctly. You can see that. So it's supposed to be level. Same thing, could not interpret label for the hue. Same thing, I've been making the same error. Okay, you can see how this label is crazy. But let me try to continue doing something here. Okay. ELT. I need to do a rotation. Takes, and we see what happens. So rotation, do a rotation of 90, I guess. It's 90. See what happens. Okay, so I've done a rotation. You can see what's happening. They're having rainfall, then the label down here. I don't know what to call this plant. So what? Let me leave them as that. So let me continue to do something here, and you watch the changes. Okay, PLT dot. Let's add a title on top of this one. Title. For requirements. Requirements. Coffee versus others. So we want to make our font size of the title just be 15. See whether you can see now how neat this now gets to look. So rainfall requirement, coffee versus others. See that. Yeah. Okay. So I'm done with this visual. The way it looks. And give you a second to catch up on that. Are we done?
I've had an error again.
Which one have you got today? Which one do you have?
SNS.
Were you able to see that you have the data?
Yeah.
Perfect. Yeah, I had a feeling it's there. But let me just basically send you this code in the chat so that we can save the time. You can copy the same. It's very easy to get something wrong in terms of label, like how I got it. So I've sent you that. So hope this one you have it. Were you having this already? Okay. Yeah, I've seen some feedback. Someone saying I'm already there. Yeah, Boaz is already there. Let me check my people here. Um, Moses, Kajimu, are we together?
Oh yeah, I think this one works. I think I might have written something wrong there.
Nice.
So this one
That's
works.
nice. Okay.
Sir,
Uh-huh.
sir,
Are we
we are
together, Mo?
together. No, we are together. Though I'm using a mobile phone. I'm kind of slow,
That's
but the thing is working out. I have not any issues, sir.
nice. Okay. That's fine. Naseje, are we together?
I'm okay,
Right, John?
sir.
Nice. Connie, I think Connie is the one supposed to dance on my video, but I still get, she did something I didn't understand. Connie, are you there? Sorry. Connie, I need to hear you. Okay, someone needs to scratch Connie because I'm not leaving until I hear her. Connie, are you there?
For me, I'm okay.
Okay, that's Vanessa. Okay. Limits, Dora. People I'm not seeing. Okay. Joseph, are we together? Ariho? Joseph, are you there? Okay. I think it's network. Okay. I could hear a glimpse of you. Okay. So I think we should be together now. All right. We can now proceed. So you can see this over here. You can see rice, maize, chickpea, kidney beans, pigeon peas. Okay, Alan, are we together? Okay, Alan, are we together?
Yes, I am here.
Nice. Okay. Banana, mango. Yeah, all those. So we have them. Okay, we can proceed. That's a visual for that. Let's move. Oh, I just don't want to be here. Should we go to the next? Okay, so let's see what we can do next. Like
There
I
may
told
be
you,
some small interpretation.
that is from Kajimo. Okay. Where are we? This is where we are. See a bit. Okay. I just want to map where we are right there. Coffee size 15. Nice. Okay, so basically, when I finish these codes, I'm going to explain further, but when you look at this box plot over here, um, when you look at the different, we are having the different rainfalls, rainfalls. I think it was in millimeters, if I've read that correctly. And then we're having the different crops that you have on this particular side over here. Let's try to look for the specific crops that we are speaking about. For example, coffee. You can see coffee is right here. So we can see that coffee has a bit of high rainfall over here, but when I finish the code, you're going to be able to see a lot of things. You'll be able to see, and we can be able to describe it further and properly. Yeah, so let me first finish the code properly there. But basically what we are trying to do, the insight behind this visualization is that if a farmer in a dry region wants to plant, for example, coffee, the graph should be able to tell us they must, for example, invest in irrigation. so that they're able to actually get to do that. So let me try to finish this code. Let me write it just below this, and we proceed. So we wanna, let me create another, make it easy. So let's do like we save the visual for our report. So remember, you're going to do that analysis, and you need to to save visuals, and so that you can use them to give reports. So save big. Okay. So exports. That's our folder that we created, if you remember. So we call this analysis dots. Want to save it as a PNG. PNG is a good format for things like pictures. Okay. So the DPI, let's set it to 300, the image. So if you do PLT dot show function, okay. So the fig size is 640 by 480 axis. Nice. Okay, so what else can you do here? The other thing you can do is let's use a comment. We can show the specific statistics, for example, for coffee. Okay, yeah, we could just simply use a print function, and so this is new line. When you do that, you can do the average sort of condition for coffee. Okay, sorry. There's some people I wanted to invite to join us. ICT department. Okay. Right done. Coffee. All right. So we can also have another print data frame. So we want to have a label. So we want to have, let's have the coffee. Describe. Oh, my power saver. We connect the charger. All right, that should do it. Connect the charger to my power. Here. Okay, there we go. All right, so we're having average soil conditions for coffee, NP, whatever, up to down. Okay, so we have all this code. So I'm going to shift this code and simply have it in one cell up here. and also shift what I've just written. Just have it right up here. Now run one cell. Okay, that looks more neat than previously. So average soil conditions for coffee, nitrogen, phosphorus, potassium, temperature, humidity, pH, rainfall. So we can tell that there's a lot of rainfall here for the coffee. So that's the piece of code. I'll share you this code so that we save time. I put it in the chart so that you can relate with it more. There we go. Yeah, so when you look at the box plots, you can see that coffee has very high rainfall. So, and we believe that maybe coffee needs consistent rain, you know. So these visualizations that you do, they should be able to communicate to a farmer and let the farmer know what they should do next, basically, based on what you manage to produce. Remember, you're getting the 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 the, the insights from the data that has been collected using the sensors. So these sensors are put in the soil and they're able to provide you with a pH, with the phosphorus and etc, the pH that you need basically to support in decision making. So we are now going to be moving to something a little bit interesting, but one of the last parts of what I want us to look at. I'm kind of, when I reach this part, I'm starting to get tired. So, okay, so I'm going to clean out these and simply clean this, and I have a text section where I want to speak about step 4. And this is going to be it's called data preprocessing. Yeah, it's going to be data preprocessing. So what happens here, we're basically translating for the AI. So we're translating for the AI. That's what we're doing there. Okay, I just saw a Twitter X from Fabrizio Romano. He's telling us that Otamendi to Rodri and Laporte after the game, you spent the whole week crying about the referee. No, he's just talking about what these guys are saying. Okay, so that's what we're gonna do. So what do I mean? So the AI cannot read the word coffee. Simple. AI read the word coffee. It cannot read the word coffee. So what do we need to do? So it only understands numbers. And what else? So we also need to split the data. And we're gonna split it into a study set and what? Exam set. Okay, so those are the sets. We want to have this data splitting. Okay, the previous will be better. I can leave it to that. That's fine. Okay. So, okay, someone is saying that, okay, I need to read that. It has disappeared. Okay, where? Sorry, I have to check with my phone. So how come they're here? When dealing with this data set, we didn't firstly describe and info finding the is now, or they're not needed for it. They are highly needed. They are highly needed. However, I just chose to focus on some of the things you've not covered because we covered that next week fully. You need to understand the meaning of the different functions that we write. For example, describe. You want to understand deeper about the data. Now, in the beginning, I read more about the data and spoke about what we're going to be doing. So I didn't need to go through describe, but you can do it and you get more understanding. Info is now, you can check all those different parameters. Very, very essential. And thank you for airing that out. They're important. I just decided to ignore them so that I save some time. Okay, so let's proceed. Okay, you're welcome, Alan. So we're going to do something interesting and something new. So we're going to use scikit-learn models. Okay, Malonga is not going to Man City anymore. Sorry, I keep saying these things. You can't believe we are learning at the moment, but at the same time, I'm watching highlights of the Champions League at the same time in front of me. This is crazy. Okay, from sklearn model selection. So we want to import. You can see that it completes that for you. I need to learn out. This one doesn't work the way I want it to work. Okay, can do imports. I'm basically writing what it has brought on the screen for me. Train test split. Okay, because it's correct. From sklearn model selection, import train test split. Then we have another from sklearn dot preprocessing. Finish it for me. Preprocessing. We wanna import. When I import, I keep getting label wrongly. We want to use a label encoder and standardizer. Oh, it's called a standard scale. Nice. Okay, so this should be fine. Let me try to see whether everything is good. Yeah, everything is good. So I'll go to the next cell. You can write in the same cell, but I just don't want it to be too much for you to understand. So our first step here is going to be, we want to first do the label encoding. Okay, so what does this mean? We want to turn crop names into numbers. Remember, I told you that AI doesn't understand the word coffee. You need to change it into numbers for it to understand. So we're going to turn the crop names into numbers. So these numbers, if you don't know numbers, start from the zero index, 1, 2, 3, da, 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 da. Yeah, those are numbers. Okay. So let's use a simple local variable of LE, and we do the label encoder. Label encoder is a function that is inbuilt within. So we do the data frame. So which one do we want to pick out? So we can do the crop ID. So when you do the describe functions, the info function, you realize there is crop ID within the data. You'll be able to see that. Okay, so LE dot, we want to fit. Yeah, I think this is how it's written. Fit transform. This is the beauty of Google Colab. It helps you finish things, so you don't have to think a lot. Come on, yeah. Okay, so I have to ensure everything is good. So I've done something wrong somewhere. Let me see if we have a crop, keyword crop. Okay, crop ID. So this is not supposed to be that. It's giving me something wrong. Supposed to be level. Okay. I can leave this. I can go to the next cell so that I don't make it overwhelming for you. I'm going to move a little bit faster now. So what you need to do second after label encoding, we are going to define the features. We're going to define the features X and also the features Y. So the target is gonna be Y. That is the expected. Okay, so we're gonna have X from, I wanna drop. So we need to have a label. I'll be, okay. Now, okay. ID. And lastly, we do the Y is equal to df of ID. Okay, what do we have here? Label non-found in axis. Okay, first thing, need to be very observant. Okay, everything is good now. So 3, sorry, I'm moving a little bit faster now. 3. So we're going to do a train test split. And like I said, these are the same steps everywhere. Everywhere. There is no difference. So when you're doing this, we always do it as 80% and 20%. So 80%, if you come back where? Where did I mention that? I don't remember where I mentioned that. It's fine. So I'll remember. So we are doing a train test split. So I just wanted to mention this. Oh God, this is 80%. That's 80% goes to the study. And then the 20% goes to the exam. Yeah. Just studying the data, then testing the data. So now we run, these are the same steps, X train, X test. Then you have the Y train and the Y test. So here you run the train test split. As you remember, we wrote it. You have your X, you have your Y. The rest has been written for me, and I'm so happy to just write forward. Test size, test size goes to 0.2. Random state. So most of this is just same. The moment you set there above, the rest is just that. Okay, this should be fine. Okay. So number 4, one of the last parts I'm gonna be doing. So what do we want to do in number 4? Number 4, we want to perform scaling. And this is the most important step when it comes to deep learning. So do scaling. And I want to say the most important step. Deep learning. Okay. So what does this mean? Let me add a little bit of explanation here so that you know. So this makes sure rainfall, for example, that is 200 doesn't choose to bully the pH. pH that might be just 6.5. Okay, let's work on this and we finish. So we use the scalar as a local variable equals to standard. Finish it for me. Standard scalar. So this is a function. You can see everything is getting written for me. So you have the X train. Okay, sorry. X train. Okay, so we are having X train scaled. Goes to scalar. You want to perform the fit transform. So when I have the X train, oh no, come on. X train, something is wrong somewhere.
The scalar has to start with capital S, as you defined it.
Scalar, X train, scaled, that's okay. Scalar, dot fit.
Yeah, equals X train equals X equals scalar capital S there.
Okay, let's see. No. No worries, I'm gonna fix it. Let me first see what I get in the error. Okay, it tells me scalar non-defined. Okay. Fine, let me see. Scalar that standard scalar. So when it comes to the local variable here is where we're supposed to do the definition of the scalar so that the scalar is picked up automatically over here. Then we are good. We are safe. Simple. So thank you for that. It gave me an insight of how to think. Okay, so we do, wow, that's given it to me already. It's test. Scaled. Scaled equals to scalar transform, X test. So X test, scaled. Yeah, I thought it's gonna stop in the error. All right, I think we are good. The last part here, I'll simply do a print so that we see something at the end of the day. So when I do data is now mathematically optimized and split. And split. But of course, we know what's going to happen. That is the output. Okay. So if you look at the standard scalar that I've been dealing with over here. So if you look at the standard scalar function, when I say scalar over here, the AI thinks rainfall is more important. And that's why I say that this makes sure that the rainfall does not bully the pH, because the AI will think that the rainfall is more important just because the number is bigger, like 200, that is bigger. So scaling simply makes every sensor equal. So it makes every sensor equal so that there is no bullying of any other thing. And the other thing I performed here that is new is the test split over here, the 80 and the 20. So we never show the AI the exam. That is the test. We never show it the test over here until it finishes the studying part. So it never gets to see this until it finishes the studying. And then when we perform the exam, we see whether we are going to attain the actual accuracy at the end of the day that proves the model is well fit for other data, outside the input data that you serve it or the data that you used in the study phase. So that's what happens. Now, where in all we've done, we actually didn't need the GPU to surprise you. We didn't need the GPU for everything we've done. Everything we've done, we just need a CPU to do. You don't need a GPU. So what do we need a GPU for? What would we need a GPU for? That's where I'm going. Okay, so in step 5 is where we would need a GPU. So step 5. So step 5 is building the deep learning brain. Oh, I'm tired. Okay, so it's called the neural. How do they write the word neural? Just with neural. It's been a while. I don't touch neural networks, neural network, stuff like that. Yeah. Okay, so now we get to utilize what we connected, the T4 GPU, to get to train neural network. Okay, nice. Okay, so if you want to train to build the brain, you're gonna need TensorFlow that we installed, that we imported before. So we're gonna do from TensorFlow. Hey, this better help me finish words because I'm tired of typing. So we're gonna use Keras. Keras. We wanna access models within Keras. Imports. We wanna import, the first one is sequential. Nice. Okay, then we need to get dense dropouts and batch normalization. So still say I'll fix that from TensorFlow. Keras dot layers. We want to import. Let's finish that for me. Import dense. Oops. Batch normalization. So I'm getting some issue. TensorFlow. Keras. From TensorFlow. Yeah, basically we run everything so that I'm very sure. I need to take another action for the error that I'm seeing. Yeah, I think it's good. It's re-imported. So what I was doing, I was reaccessing these upper importations over here that we did so that they can communicate down here. It shows me that everything is good with a tick, but I don't know why it's bringing that. Fine. Okay. Why is it bringing this? Could not be resolved. Missing inputs. Right. So it's telling me this. So if you're troubleshooting and you're alone somewhere, you'd do this. I would basically continue there. Of course, we used to use a lot of Stack Overflow, but now I don't need that. You can just come down here and you see from Keras import models from Keras models import sequential. Option A, import TensorFlow as DF. We have that model equals to tf.keras models.sequential. Option B is interesting. Let's try this and see ourselves. So that's still seeing something I don't want to see. Look at this option here. Does it correspond? TensorFlow with pairs. It doesn't. It's purely the same thing actually. It's fine. Let's go on and then see what happens. Let's see what we get later. Okay, so we go into the next step, which is encourage impact models. Okay, just a second. Look at something here. Okay, that means I don't need those. Submodels directly from the main package and use standalone Keras. Okay, interesting. That is what it needs. Got TensorFlow as DF, then df.keras model sequential, then it will import it. Fine. Okay, I've seen what it needs. I don't even need to do this, but so what was I doing? I'll just put these two methods right here. I'll just put them right there. And I come here, building the architecture. Okay, so we want to build the architecture. So model, local variable. So we want to say equals to sequential. I think sequential is a capital. Fix. Actually. No. Okay, 1 to 8 rule, input shape, X-train. Okay, that's fine. So we write this the way it is, 1 to 8. activation. So we're gonna use rel is a function, an activation function within convolutional neural networks. If you study the mathematical sides of activation and what happens. So much of that mathematics has what we call the back propagation, which is recalculation of the error after doing that simple mathematics. So that's why I say that I wish we had a physical moment for me to teach you guys that mathematics. You'd enjoy it. Okay. Okay, so something else failed to work the way I wanted to work. Okay, so we're going to describe a lot of things here. The batch, normalization, function, dropouts. Most of these are just the same. Dot 3. This time around, yes, dot 2. And then 64. So activation we're using rel. Normalization. Okay, so just write one more and stop there. Dense lengths. Okay, so we pull the LE dots classes. Um, Version. Let's start. Softmax. So this softmax is for multi-crop probability. So I'll just put maybe something like this. Softmax is probability. Okay, now I'm gonna stop on that. Push and follow that. I think we had brackets. Do you have brackets to start with? I think when you wrote sequential is a function. So this was supposed to be within a function. Yeah. Okay, fine. You can fix whatever error we get. We do. Want to pass an input, sharp input measurement to a layer. When using sequential models, prefer using input sharp object as the first layer in the model instead. Okay, let's look at what we've done. Model DL sequential, dense 1 to 8 cultivation ReLU. Input shape, extrain, cult, dot shape. Yep. That's batch normalization. We have dropouts. We have dense and activation ReLU. Batch normalization. We have dense survey classes. Have activation. Softmax. Then that should be fine. Okay. So we can have, okay, that's given what I was looking for. Model DL dots compile optimizer. So we have another optimizer. We have an optimizer called Adam. Or someone speaking that you need to read about? Adam. So the other one was an activation function called ReLU. Read about it. Now you have to read about an optimizer called Adam. There is a lot of writing on them that you need to read so that you can understand, because these are advanced concepts that require your foundation to do the mathematics, and I show you how they come about, what they mean. But now we've chosen to do this, and then we can see if we have a session for the mathematics. Spatial, space categorical, cross entropy. All these are within the math for you even start doing the coding itself. And it's basically from the math you studied from high school, probability theory. It's called the Bayesian theory when it comes to machine learning. I used to teach that like 8 years ago. 8 years ago, I used to teach it. I taught it for over 7 years. Before even AI came into like so much shape in 2021, 20 there. Before that, I used to do it already. I didn't know that it will hit the market crazy, but then later I hear everybody speaking about AI and I'm like, oh, okay, interesting. Okay, so let me do the last part of the training, the model, and hope it works. And then we shall end there today. It's been a lot. So just to, but remember, you need to find data. You need to do everything I've done with your data. I need to see a full project. And so that you explain to me everything step by step, the way I have explained as we've been studying. So training the neural network. Network on GPU, because this was one of the main reasons for connecting the GPU. Okay, so training. So I'll start with a simple print where I just want it to, anyway, that print is enough. The one I put. So we can start with history. History is written like that? No, sorry. History. Yeah, history. That's just a local variable. So model dl.fit. So when I get the X train scaled, and we want to get the Y train. You can set out things like the airport, whatever. You know, for me, I'll look at the validation data. Okay, then I'll set the X tests, the one that is scaled, and then the Y test. The Y test. I can as well specify the airport. It's something I did wrong somewhere. I can set them to 50. So these are adjustable still if you study further machine learning. You need to learn about the epoch. You need to study about the batch size, what all these mean, and also the variables. So when you training and dealing with the data, then you're gonna need to understand them because you keep on playing with them, you know, getting them together. So I'm gonna have to trace a simple something I didn't do well somewhere here, but I'll trace it from an error. Let me do a print. Print F. I want when it completes, training complete, then final accuracy. So the final accuracy, I want to get it from the variable history. History dot the history. So I want to get the value accuracy. How did I write the word accuracy? Accuracy. Yeah, I think it's written like that. So we don't want to run into infinity and things just go crazy with us. 100. I want to decimal places of the output. Yeah, so let's see. I'm having some error somewhere. Yeah, could not interpret loss identifiers as categorical. Yeah, history. Yeah, I knew something is wrong somewhere. History model dl.fit xtrain scaled I train value error could not interpret loss identifiers plus cross entropy. Not interpret loss identifiers plus. Okay, so allow me get these codes in the same area so that I can trace it well. Let's put it here. We need one error. Okay, now let's look at it properly. History variable. Eight. Okay, that's fine. Interesting. Okay, I need to get it from app model.dl compile. Optimizer. We're gonna use Adam plus sparse. Categorical. Okay, let's fix something here. See. Categorical force entropy. Okay, we are good. So it's now training the neural network on the GPU, as you may be seeing. Okay. So training complete, fine now. Accuracy is 98.18. This is an outstanding accuracy levels, it's an outstanding accuracy levels. Yeah. And okay. Let's look at this a little bit before I close the chapter. So if we look into this, basically, this is where I started defining the neural network. I set 128 and also the 64 that you see over there. So these are like the layers of the experts, the experts, who are discussing the soil, basically. And then I mentioned about the dropout, which I gave the 0.2. So this is like a teacher making some students close their eyes. So the rest of the class has to learn to solve the problem without them, when they have closed their eye. So it makes the model smarter, basically, the moment you do the dropout, it makes the model smarter. And then there's somewhere I spoke about something else, the softmax over here. So the softmax, we are wanting the output to be a percentage, basically. And we are getting an output of the 98.18. 98, this is pure coffee for real. So this is for coffee, the soil, basically. Okay. We can do a lot of things to basically test the model. We can test the model. We can use a real world Ugandan farm and then we test the model simulation, Let's say that a farmer brings the soil to you now, Okay, I know it is 1 something. We are not going to have a session at 2 p.m. So let me just use just 5 minutes, even if my belly is storming crazy, but I think this part is very important. Guys, are we still together?
We are together, but
Yeah. Then this area, right?
yeah.
I knew it. Yeah, this area is crazy. I wanted to try out something, dropping that away.
So you can share that code.
I just do this. Suffix. Okay, I just cleared something I didn't need to clear. I just cleared a cell. So that means I need to add that cell. Okay, so I need to add the cell that I've just cleared. I was wanting to try out something. I think it was like from... Yeah, of course, I'll upload this recording. I believe in you going back to the streaming and then you do things without copying and pasting. So I'll upload it, models. I think this time I should do these uploads today later.
So I have a question.
Yes, please bring it on as I finish this.
Do the accuracies keep changing? Because I've seen yours is about 98.16, but mine is 98.64.
Mine is 98.14. Yours is 98.1? 1?
64.
164.
98.64.
Wow, yours is higher than mine, I guess. Yeah, yours is higher. That's 99. That's 99. Wow. Yeah. So I'm not so sure. Your model performed better than mine. I like the fact that you were running so fast to reach me. Okay. Thanks. About. Yeah, I think that's what I had lost. Nice. I think should be okay. Okay, so I wanted for us to do quickly something simple away from using the same model, basically. It was I wanted to do it. Yeah, now I'm getting a 97.95 when I did a rerun of that, you know. Yeah. So that variation happens, but of course it's still up there. So real world tests. This is the Ugandan farm. Crazy keyboard. Ugandan fun. I wanted to do a simple simulation just to see how we can shift the idea. So I'll call this the moments of truth, where we simulate a farmer bringing soil sample to the students. Okay. Okay, fine. Okay, so let's do something simple here. So let's assume a farm in Mbale, which has specific soil tests. So if you look at Mbale farm, this Mbale farm here, we want to capture the PD dot data frame, I guess. Yeah, the frame. So we're going to name the nitrogen according to the data being provided. So let me, it's a string, say nitrogen. So the nitrogen, let's say, now this is new data. We are trying to expose our model to new data. Before it used the data for training. Now this is new data. This is new X, basically. I need to teach you that mathematics so that when I speak about new X is very clear. This is new X. So phosphorus, let's say phosphorus is 45. So actually you could still also do this. You had a different result. So try to do this so that I see what you get with your model. Potassium, let's say potassium should be what? 42. Yeah, just random numbers, 42. Okay. How come my K is behaving weird? Okay. We need to as well capture temperature. So temperature. Temperature. Okay. We need this temperature to set it to 22.1 for this region. What else? We can also set humidity. You can also set humidity. So we want to set humidity to, let's say, 83.5. And what's missing? pH, I think, according to the table. pH. You can make this pH to be 6.2. 0.2, maybe. What's missing? Sorry, let me go up a little bit. I want to look at so NPK, temperature, humidity, pH, rainfall. Okay. Okay, down. So the last one is rainfall. So rainfall, we can set it to the precipitation 208. 2.4.
Now, why are we leaving out label?
Going back up. Yeah, so if you look at this is basically the type of the crop here, which is basically rice. And we are trying to look at a farm that is specific. So we are looking at these parameters which are specified here in the data itself, specifically the data fields. And if you look at them, we don't have label. Label is basically for the type of crop, basically, which is a bit separate. That's why we are leaving that out. Okay. All right. Let me see. Oh, did this work anyway? I need to check if I have an error. Okay, yes, it works. Okay. Let me just run a cell here and see what we can do first. So we want to perform a scale. We want to scale this sample. So we can do sample scales. This is just a local variable which we shall call later. So when I use a scale dot transform. So we want to transform this Mbale farm. This one here. We want to transform Mbale farm. The scaling works. Then the second last, we want to do the predicting with the deep learning. Okay. Okay. So there's something I was just trying to recall. Let me just pause there a little bit and I look for it before I forget. It was open notebook search notebooks on the drive. Yeah, it was saved as a GitHub list, save as a copy in the GitHub, copy in the drive. And I click this Is waiting for authorization. Okay, I'll try to save that in the GitHub later. I just thought about that function, whether it's still within there. Okay, so this is long. So we're gonna do local variable prediction equals to model. This thing better finish this for me. dl.predict. So I wanna handle prediction. So we need the sample scales. Oh, it was bringing it for me anyway. Just set these variables to 0. You need to read about these things as you repeat. So predicted, I'm gonna set a predicted ID. So we can do the NP dots. Now set to edge maximum. So this works for me here. Prediction. Document. Prediction, that works for me. Okay, that written for me the next parts, which I think I need. We can decide to let's do crop name. So we can use that reverse transform. Get the predicted. If I get an error, I'll fix the error. There's something I'm noticing. It is a bit outside what I'm thinking. Fix that. Then we can define the confidence level. The max prediction. It's 100. See whether I have an error with this because I sense something. Huh. Okay, maybe it will alert me later, I guess. Okay, the last part where we perform a few print statements. So we can print times 40. Ah, I see. I'm just wondering. Okay. Okay, that's corrected itself, thought. So print report from Bale Farm. These are just string words from Bale Farm. And I have another print. Recommended crop. So remember, it's going to recommend a crop automatically. Someone was asking me, why didn't we put the label? So we shall get the crop name captured here. Hope it works anyway. But when you're tired, you just do things. Okay, what else? We check the AI confidence. So last one. F. All right, confidence. Yeah, it was written it for me. Where is it? Confidence. Joao Gomez joins Villa. Wow. No, these are the problems of supporting certain teams that do not have money properly. You suffer. You see other teams buying players, and for you, like, okay, we shall be fine. But we shall win another Premier League, so we don't worry. Okay, so I'm really tired already. Okay, stop right there. So yeah, let's see. Hope it works. Yeah, so it provides, so you can see report from Bale Farm, recommended crop is rice. Confidence level is 85. There is something I'm gonna do that is interesting, but let me try to provide, show you how you can get the links in. Then I'll do a little trick. So for the reports, we can do prints. So if you're providing reports anyway, this is a new line. So if you want to get visual reports, oh, I didn't put that in the beginning. Okay, so this is display. Now you can use the file link that we imported. Do exports, rainfall analysis. It's PNG. So this is the link over here. So if you click on that link, it will automatically have to generate that PNG on the local host. I don't know why it's not loading, but that's how you put it. Rainfall analysis exports. Yeah, so I wanted to do a little trick. Let's raise this temperature to 3 and drop this pH to 2. Yeah, you can play around with the right numbers, so it stays on the right, but now it takes it to 99.98 in that case, the AI confidence levels. Okay, let's see. Oh, here they don't specify the data points. I wanted to use their data points. Yeah, but I think this is something you can do for yourself, and you check the different crops. And you see what happens with the model. I'll just change a few values. Yeah, and then see what happens. I think that's it for today. Do you have any questions? So still rice, but the confidence level is totally down. 63, you don't plant. The other one was much better. Yeah, so you can do with a variety of crops, and then you test and then see what happens. So
Can you go
I
down so
wanted.
that I can finish writing a little bit? Just for a few
Pardon?
seconds. Can
Pardon?
you scroll down to the end of the JPEG?
Ah, the end. Okay.
Just want to finish writing. Yeah, right there.
Okay.
Yeah, that is good.
All right, thank you. See, okay. Stop the share a little bit, and then I click on pushing it to save a copy. Save a copy to the drive, save a copy in GitHub. Yeah, let me first do this. Just didn't want to just expose my authorized Google Colab. That's fine. Verify email. That's okay. Let me just do this very first, and I get back to you. Verify. Now GitHub, yes. Verify. It's verified. Okay. Main C3 detection. Put it there. Yeah, just a minute. I'm trying to get a few things clean here. Repository. Copy detection. No, I'm not gonna put it in that. Just set up a new repo here very fast. A new repository. What did we call this? Farmer soil prediction. Crops prediction based on soil type prediction. I'm setting up a repo, so I'll share you the link. ML machine learning. There. Sites and machine learning. Make it public. No. Paid repo. That's fine. Okay, repo is created. Okay, that's fine. Need to just simply refresh this. Okay, select copy. Oh, come on, they want that. Select copy. Select copy. Yes. All right, so I think this create a branch now. Link to collab, that's fine. All right. Okay, so I have my private coffee detection. Where is it gonna have? I have my private GitHub. So be a link in the new tab. Link address. Okay, let me show you this link address. I just have a private repo, which I use for private stuff. Okay, this is a private repo right here. So it's called farmer crop best and soil whatever, soil type. So let me try to show you that link. You'll access codes right there. So I've sent you that. You just basically fork it, and then you get it. Yeah, so it's right there. Okay, so I'll stop the share. All right. So guys, it's been a very interesting session. Imagine we started from 10. It's now 1 something going to 2. That's such sessions really take a lot of hours, but then thank you for all being on the call. So let me get some feedback in just 1, 2, 3. Namik, were you following or you joined a bit later? I think I didn't see you before. Namik? Yes, Vanessa, you have your hand up.
Thank you, sir. So I'm asking what okay um logbooks, because
Pardon?
I am logbooks. What
Like
time are you
what
available?
time? Are you a
Are you
physical intern?
available? No, online.
Yeah, yeah, like I said, I have to schedule for online and I'll text in the group. Um, yeah, because you know they are physical, there is online, so that means I need to schedule that, and I'll communicate at least a few hours before I schedule that. Uh, the physical guys have not yet completed, I think. I need to also start capturing marks for that. And also, if I'm to capture marks, you need to have a project completed. And the project is you need to find data, like we found data today. Then you work on a project from start to the end, like where we've ended today, completely. And you should be able to explain that project from beginning to the end. And that's how you're going to earn the marks. Because later you need to train a model. After training a model, you need to introduce a new model. Sorry, you need to introduce new data from a different location, and then you apply that data to the trained model, and you see the levels of accuracy, what it tells you, the prediction at the end of the day, just like we've done. And we shall interact. And if you answer all my questions and everything, then that's how you'll get the marks at the end of the day. Hope I've answered you, Vanessa.
I
Did
have a
I?
follow-up question on that.
Yeah. Vanessa, did I answer you?
Yes, sir.
Okay. Yes. I think Madit or someone was speaking.
Yes,
Mm-hmm.
with my date.
Yeah.
Yeah, I just have a question regarding those people who joined 3 weeks later, like some of us.
Mm-hmm.
And I don't know, how do you want us to start feeling like, like, how do you call it? The or for the internship logs, how do you want us to feel it? Because are we gonna
Yeah,
start
the log.
from the day that we start,
Yeah,
or how
no,
is it?
you're
Because we are now in
supposed.
around day six, right? We are around week 6 now, but some of us are they just joined, so we are about 3 weeks into the internship now.
Yeah, the thing is, you starting late. Sorry, it's going to this channel. You starting late. We don't know what caused that. The program started early, and what we did was to record every session for you, so that whenever you come, you can simply catch up with the program. And like I mentioned before, you have to start from week 1 when you're filling the logbook. And the explanation is simple. Um, Everything that was covered in the first week when you missed, it was uploaded on the YouTube channel. So if you're doing data science, you don't need to go through everything. You need to go through two things, three things. You need to go through the Git and GitHub, as you may see. Git and GitHub, and I think it's repeated like 3 times, moving on to that. So you need to go through this Git and GitHub. For web development, web are the ones who go through the React and whatever. Prompting, this is part of what you have to fill, and everybody, you need to fill the prompting section. Merging conflict as Git and GitHub, still I expect all of you. Then Trello, I expect all of you to fill. This is project management software. AI tools and systems architecture, all of you have to fill this. So these are like over 4 weeks I've mentioned already. Then this one is for web people. The other sessions, I'm going to upload them. I should do that today. So you're going to have more sessions uploaded today. I'm going to do that. So you fill from week 1, even if you are not available. And then up to where we are, week 6. I should expect that done. At least do it before Tuesday, because I may choose to meet you guys Tuesday or Wednesday, the online and the physical. Is that clear?
Yeah, that's clear. It's just that you mentioned about uploading the videos because some of the videos for the past week that we missed, some of the videos are not there. So
Yeah,
it will be
yeah,
great if you upload them. Thank you.
yeah. I'm going to upload them. Those videos. Last week, I think that's when I lost my laptop. The one I'm using is a new PC, and like I mentioned, these PCs are expensive. So it took me some time to raise
Sorry about
11
that.
million. Yeah, but I got the PC, so let me check these recordings as you're watching. The past week, if I'm to check in my system of recording, yeah, I got really challenged in the past 1 week or two. I couldn't even be on the call for some sessions. Yeah, so I have most of those sessions. The last one I uploaded 13th July. So 13th July. So from 13th July, applied AI data science. So that's where I'm starting the upload from 13th July up to where we are. Let me see. 14th July to 20th. So these ones were frameworks, AI tools, analytics applied. I'll review them and see which ones are active. Applied. Some are repeated. Venture economics, I'm going to upload these two, either of the two frameworks, and these are the ones that manage to save themselves in here. Yeah, all right, I'm going to do that. I'm going to do that. Yeah, I think from around here, July 6th, moving forward. Okay, thank you. Any other question? Some money. Alan, you never stop. Okay, you guys have a good afternoon. Let me take a little, I don't know, I think shower, and then I'll get to the next sessions. We are not having an afternoon session. I'm going to just do me, and I have a lot of other things to do. I have a very, very serious project. I could, you guys, I could show you something here. This project is crazy, drives me nuts, all the time. But it is something that is going to transform this world somehow when completed. Let me show you so that you see. It's a PhD project, basically. Yeah, so it's this project I'm doing here. Of course, I'm doing it from South Africa, so you can see that I'm accessing some data from Cavendish University. And it's an AI strategy coach. So it basically helps you to get your strategy right in terms of setting initiatives. So it's basically meant to, it's more like a tool that helps you have the right idea at the end of the day, because people have a lot of ideas that do not have any supporting kind of thoughts or ideology or whatever, background and etc. So you find that you're dealing with people with crazy ideas. So I'm not telling you exactly what it does, but I'm giving an example. So it's more like if you're thinking and you're a student, you want to come up with an idea that is going to scale and it's going to be sustainable. You just come with it to the tool and then you interact with the tool. And at the end of the day, you're going to have something that the market is going to accept. So some of the information in the back in the engine is the market kind of information, the different validations, the URA, URSP, data points, and all that help to validate your idea at the end of the day. And it has quite a lot of different things, the semantics, it has, it does quite a lot of different things. But this is to do with it's to do with the corporate kind of level businessmen, basically. Running corporate companies and businesses, basically. So it's a little bit different. Yeah. So thank you. Have a good afternoon.
Thank you so much.
All right.